Okay, so we are starting notes on trig ratios and understanding the angle of elevation and depression. So hopefully you took and copied these. I uploaded this blank notes for you on Google Classroom, so hopefully you got that so you can follow along. So we want to measure the height of something that's inaccessible, something like a tree, a building, a pole, anything that's tall that you can't actually physically measure. So we call these indirect measurements. To solve such accessible heights or depths using trig, the following angle definitions are necessary. So understanding angle of elevation. So when we look at angle of elevation, we always want to think about our line of sight. So think of that horizontal line that you draw straight across, and then what you're looking for up here could be a bird, it could be at the top of a building, but that angle that's formed in between the horizontal and your line of sight. So think of the horizontal line and the line of sight as the sides of your angle, and you are looking up, so that gives you your angle of elevation. So you really have to understand what I'm referring to when I talk about the angle of elevation. Okay, so again, it's the horizontal line and your line of sight when you're looking upwards at that object. So let's look at an example. Here it says the angle of elevation is 40 degrees, the angle formed when looking up to an object, being a tower. I'm standing 20 meters from the base of the tower. How tall is the tower? Let me make that a question mark. Okay, so here's my tower, and I don't know, I'm just going to draw something like that, being the tower. And I'm standing over here. And the angle there is going to be a right triangle that you're looking at. So we're going to just not worry about the height being up here at our eye, just for ease. Instead of having to add on your height of your eye, we're just going to take it from the ground. So the distance that I'm standing from where the tower is to where I'm standing is 20 meters. The height of the tower is what we're looking for. So I'm going to call that T to represent the height of my tower. And it tells me the angle of elevation, that angle is 40 degrees. Again, I know this isn't exact because my line of sight would be up here, and then I'd have to add on my height. So let's just go with this simple one here. This is our hypotenuse, and I hope that you see the triangle here. So let me trace the triangle. It's a right triangle that we've created. We know two pieces of information. We know the angle and we know the distance, and we want to find this. So looking at where things are located: opposite, adjacent, and hypotenuse. The two pieces that we're going to use are these two. So we're going to use tangent. So using tangent to calculate this, we have tangent of the angle is equal to the opposite T over the adjacent 20. And we calculate that. Show me what you're putting in your calculator. When you put that in your calculator, you should get 16.78 equals T. These are application problems, or sometimes students call them word problems. So I want your answer to be related back to answering the question. So here's the work, the justification. The answer is the tower, or the height of the tower, is approximately 16.78 meters. Okay, the units are important. So you can either write 16.78 or 16.8 meters, depending on whether you round to the nearest tenth or hundredths. It doesn't tell you, so you can choose. All right, let's look at the next one. So we just did the angle of elevation up here. So now we're going to do the angle of depression. Depression means something down, looking down. So this is the angle that is formed, again, by the horizontal and your line of sight, but this time your line of sight is looking downwards. Remember, this one up here, you were looking upwards. So angle of depression, you are looking down. So here is an example of a submarine submerged 500 meters below the water, and there's a ship that is 725 meters away, and we want to know what is the angle formed between the water and the submarine. So I'm going to sketch a picture, and then we'll take a look at that. So here's my rough picture. It's not beautiful, but it is a picture. So here is the boat, or the ship that's got stuff on it, and the distance from where it is to where the submarine, we don't know what that is, but we know that when we look at the horizontal right here and our line of sight, this angle right here is what we are trying to find, because it says what angle is formed between the water and the submarine. So here's the water, here's the submarine. What is that angle? We know that it is 725 meters from the ship, and we know that it is 500 meters below the water. So from here to here is 500 meters. The closest distance, when it tells you how far it is from the ship, the closest distance is going to be this distance that we're looking at. How far is it from here to here? So to measure that, it would be 725 meters. Okay, so using all of that information, we're going to calculate. Because we're looking for the measure of an angle, because we want the measure of an angle, we are going to use an inverse trig ratio. Which one are we going to use? Well, let's see. From this angle, this is our opposite, and this is our hypotenuse. So we're going to use the inverse sign. So the sine of the angle is equal to 500 over 725, but because we want to find that measure, we're going to use the inverse sign of that ratio to get the angle. And that is going to be 500 over 725. There is no need to reduce that because you're going to put it in your calculator anyway. This is going to give us the measure of the angle. When I put that in my calculator, I get 43.6. So the angle formed is 43.6 degrees. So there's our answer. The angle formed between the water and the submarine is 43.6 degrees. Okay, let's look at the last example. I thought I had one more. Let me see. Ah, here it is. One more example. So this example is a kite flying above the ground. So there's a kite flying above the ground. The length of the string is 150 feet. It's measured from the ground. Find the angle to measure to the nearest degree. Okay, and you're finding the angle the string makes with the ground. So here's the ground. Here's a person standing over here on the ground. Here's the kite flying up in the air. Here's the string that's attached. So here's our right angle. Here's the string. So it tells you that you want to know the angle that is formed with the ground. So I don't know what that angle is. I know the kite is 115 feet above the ground. And I know that the length of the string is 150 feet. So the length of the string measured from here to here is 150 feet. So this is how far above the ground it's flying. This is how far the string is that the person let out. And we are supposed to find the angle that it makes with the ground. So what is this angle right here? As I look at what's given from this perspective, this is our hypotenuse, this is our opposite, we are going to use sine. So sine of x degrees is equal to 115 over 150. Again, I'm looking for an angle, so I'm going to use the inverse. The inverse of the ratio gives me the measure of the angle. And we put this in our calculator, and I get 50.055. The question is to round it to the nearest degree. So my answer is the angle formed with the kite and the ground is 50 degrees. There's our answer. This all is our justification. Okay? I think that's it. So that should be enough for you to go ahead and finish working on that assignment.